Welcome, ladies and gentlemen. This is section 1.1 and 1.2 of Miss Quinn's geometry. Let's start with some definitions. In discrete geometry, a point is a dot and a line is a set of dots in a row. Let's see what that looks like. Here's my dot, and here is an example of a line. Let's pretend those are all nice and straight. A horizontal line is a set of dots in a row that is horizontal, kind of similar to the one I just drew. We want to keep it as linear as possible, but it's just a set of dots in discrete geometry. An oblique line will look like an oblique line that we're used to seeing. It's just made with a set of dots. And a vertical line is, of course, up and down, and vertical row of dots. All right, if we want to draw two lines that intersect and have one point in common, the easiest way to do that would either be with two oblique lines, or you could do it with a vertical and a horizontal line. Either way. To draw two lines that intersect but don't have any points in common, that one's a little trickier. Let me draw my two oblique lines. And you can see, I don't know if I like that very well. Let me try it one more time. How about make it a little closer? You can see that they just don't intersect at any point. All right? Some definitions, again. In discrete geometry, a point is a dot. In synthetic geometry, a point is an exact location. In discrete geometry, lines are just dots in a row. And in synthetic geometry, lines are sets of points extending in both directions, containing the shortest path between 2 points. You're probably more familiar with synthetic geometry, and that's what we will utilize most this year. All right. Lines in synthetic geometry are dense because between any 2 points there's always another point. If I draw a line that looks like this, it is obviously dense because if I have point 1 here and another point here, hopefully you would agree, I can find another point in between those two. And it really doesn't matter how close I make those points. Maybe I should call them A and B, 1 and 2, 3 and 4. Those aren't numbers, they're points on the line, but whatever values they have, and no matter how close they are together, we can always find another point in between them. Now the distance between point X and Y on a number line is simply the absolute value of their difference. So notice that here when we find the distance between A and B, we don't draw a line above it. If there's a line above it, that means line AB. And if we just see AB, that means the length of line AB. And it's the absolute value of the difference between their endpoints. All right, for tomorrow, I would like you to try these two questions on your own. Use a series of dots to form two lines with 2 points in common, if possible. And on a number line, find the distance between -42 and -911. And I will see you tomorrow.